All right, so what we're going to deal with is a rule about what we do if we have the square root of a number squared, or a variable squared for that matter. So it is very tempting to write that the square root of a squared equals a. But the next example shows that as a rule, this is untrue. So if I did the square root of 8 squared, well, that's just the square root of 84. And the principal root, like I said, this is going to be a principal root. The principal root of 84 is 8. So we got 8 squared, and then we get 8 out. However, if we put in -8 instead, -8 squared is 64. So the square root of -8 squared is just the square root of 64 again, and I get 8 back. So even though this was negative, I'm getting positive 8. So what this means is that we should not put in a negative square a negative number, take a square root, and get a negative back. And that is simply because, like I said, we're looking only at principal roots. So once I square that, the negative is gone, and I'm just looking at that principal root. So this brings us to a way to simplify this. So if a is positive or 0, then the square root of a squared is going to be a. So if I did the square root of 5 squared, 5 is positive, I expect to get 5 back because I'm going to get that principal root of a squared. If a is negative, so I'm doing the square root of -5 squared. The square root of a squared is going to be -a. So remember, here a is 5, here a is -5. So I'm saying I'm taking negative of a, so -5, and I get 5 back. So if a is negative, the principal root of a squared is going to be the opposite of a. So another way we say this, and we're going to say it again in a moment, is that for any a, square root of a squared is going to be absolute value of a. We should always get a positive root back because we're only getting principal roots. So we're going to use the calculator to approximate each of the following. Or not calculator, we don't need a calculator. We're just going to figure this out by hand. We're going to figure this out. So the absolute value, I keep saying that, the square root of 3 squared, all I have to do, like I said, I know that 3 squared is 9, the square root is 3. So I'm just looking at that principal root, it's just 3. If I do absolute value, once again, it's not absolute value, I'm sorry, because I know I'm going to do an absolute value. If we do the square root of -3 squared, we're going to get back the absolute value of this number, or another way of saying it is we're going to turn the negative back into a positive. So you can look at it as either way. This case, you got to be careful where that negative is. Here, we had a -3 squared, so we were squaring the negative. Here, we're not squaring the negative. This is just the square root of, negative, and then 3 squared is -9, which is just undefined in the real numbers. So for any real number a, the square root of a squared is absolute value of a. The principal non-negative root of a squared is an absolute value of a. So it doesn't matter what it is. -10 squared, well, what I'm going to get back is absolute value of -10, which is 10. If I do the square root of 10 squared, I'm going to get absolute value of 10, which is 10. Another place this is useful is that if I was doing something like, just to piggyback off this a little further, if you're dealing with variables, So let's say we had 9x squared. Well, that's the absolute value of 9, or sorry, not absolute value. That's the square root of 9 times the square root of x squared. So this is going to be 3. And according to this, a squared is going to be absolute, square root of a squared is absolute value of a. So square root of x squared would be absolute value of x. So one of the things you got to be careful of is that sometimes when you have a variable underneath your square root, we have to decide, does it stay under the square root? And if I can pull it out of the square root, is it going to be an absolute value or not? So for each of the following, find each of the following, assume the variables can be represented as any number. So in this case, we have y plus 3 squared. So we get absolute value of y plus 3. And it's going to stay that. If I have square root of 12, m to the 12, well, that is the square root of m to the 6 squared, right? So that means my solution is absolute value of m to the 6. So in this case, because what we're dealing with is m is multiplied 6 times, an even number of times, this is just going to be actually just m to the 6. It's going to stay positive. So for an example, if these were all negative ones, and we multiplied those all together, we have a even number of negatives multiplied together. The negatives all cancel out and we would just get 1 back. So that being said, if I have m to the 6, I don't need to have those absolute values because it's going to already stay positive. So in that case, it's just positive anyway. If I do a square root of x to the 10th, well, that is x, fix that, x to the 5th to the power of 2. So that is absolute value of x to the 5th. That one we'd have to keep it because if we have negative 1 to the power of 5, that is going to stay negative 1. If we just had x is just 1, then we have all positive ones. Well, then it would be positive 1. And we want to make sure that what comes out stays negative, stays positive. So in this case, I have to keep the absolute value. And like I said, you're just trying to think about what happens if I have a negative number and I multiply it 6 times. Well, the response would be positive. I don't need that absolute value. Well, if I had a negative number and I multiplied to itself 5 times, well, that's going to keep being negative. So I need to keep the absolute value. So take a moment with these ones and decide how we would write them. What is being squared? So what is being squared is what's going to keep as an absolute value. So we have square root of, in parentheses, x plus 3 squared. So this all in here is my a. So I will have absolute value 7x squared. And since I can't guarantee x is negative or positive, we can leave it like this, or since 7 is already positive, we'd say 7 times absolute value of x. So here, this is a square root of 64 times the square root of x squared, because both of those are squares. The square root of 64 is 8. The square root of x squared is absolute value of x.